Hey guys, welcome back to Home Academy, and today we're going to be learning how to differentiate a given function. So what is differentiation? Differentiation is a calculus topic, and it involves determining the gradient function from the original given function. And this represents the rate of change of y with respect to x, and it's usually called the derivative, and it's usually denoted by dy over dx. And so how do you derive a given function? So for each term, you have to multiply the term by n, the exponent, and then minus 1 from the exponent. So from y is equal to kx to the power of n, we can get knx to the power of n minus 1. It's much easier if we look at it in terms of an example. So we're going to work through a few here. So here we have a curve has an equation y is equal to x cubed minus 3x squared minus 9x plus 1. Use differentiation to find the derived function dy dx. So so from what we learned, we have to multiply the exponent here, which is 3, to the term, and then minus 1 from the exponent, so 3 minus 1. So the whole term, when derived, is 3x to the power of 3 minus 1, also equivalent to 3x squared. And then we do it for this term as well. Minus 3 times 2, the exponent, x to the power of 2 minus 1, and you would get minus 6x. And then this term as well, minus 9 multiplied by 1 because it's x to the power of 1, and then x to the power of 1 minus 1, which is x to the power of 0, which is also 1. So it's the term when derived is minus 9. And usually we ignore the constant here because it's x to the power of 0. So we would multiply the whole term by 0. So um, the whole the whole term just disappears. And then find the gradient of the curve when x is equal to minus 2. Um, so to do this, we have to substitute minus 2 into the gradient function we found here. So substituting, and we will get, we'll simplify it into 15. So the gradient of the curve is 15 when x is equal to minus 2. Okay, for which values of x is the gradient equal to 0, so we just equate the gradient function into 0. We can use the grouping method, which we learned from the past video from the videos that I've made, and we can factorize it into 3x minus 9 times x plus 1 is equal to 0, and then we use the zero product property. We can get x is equal to 3 and x is equal to minus 1. Here's another example. It's much shorter. So it's a bit blurry, but it says here 2x cubed plus 3x squared minus 5, and then find dy dx. Again, we multiply the exponent and then minus 1 from the exponent. So 2, 2 times 3x to the power of 3 minus 1. We get 6x to the power of 2. And then 3 times 2, which is the exponent here, x to the power of 2 minus 1. And so we get 6x here. And we ignore the constant as mentioned earlier. And last but not least, we have y is equal to x squared minus 4x plus 1. But for this curve, find dy dx. dy dx is 2x because you multiply by 2. You multiply the term by 2 and then minus 2 minus 1. So 2x minus 4 because x to the power of 1 minus 1 is x to the power of 0. So that's multiplied by 1. And so the coordinates of the turning point is when dy dx is equal to 0. And so we equate this function that we found before to 0, and we can get x is equal to 2. And then we can't forget to find the y, so we substitute x is equal to 2 back into the original function, and we'll get y is equal to minus 3. And so you have to represent this in complete coordinates. And state with a reason whether the turning point is a maximum or a minimum. The turning point is a minimum because the constant here is 1, which means it's positive. So it's a positive parabola, and so it's a U shape. So the turning point would be a minimum. And so the last one would be find the equation of the line of symmetry of the curve y is equal to x squared minus 4x plus 1. Um, the line of symmetry would be where the turning point is, so x is equal to 2. So that's it. Thank you for watching, and I'll see you in the next video.